This is a study of evaluation and enhancement of road safety features, which is skid resistant, surface texture depth, and drainage efficiency on UiTM Shah. This is our team members. And the site selection for our study is at College Perindu, which is Jalan Tegas 1/15.
Problems that we have found on the selected locations is where the road experiences regular traffic from students, staff, and local vehicles. Frequent vehicle movement, including motorcycles and cars, can increase the importance of adequate skid resistance for user safety. During rainfall, water may accumulate on the pavement surface if surface texture and drainage are insufficient. A low texture depth can reduce the tire road friction, where it can increase the risk of skidding. The area's tropical climate with frequent heavy rain makes surface drainage performance even more critical. Also, repeated traffic loading may gradually polish the pavement surface, reducing its microtexture over time. Therefore, there is a need to assess the skid resistance, texture depth, and drainage characteristics of this road section to ensure it meets the safety performance requirements.
The objective of this project is to understand and assess how skid resistance, influenced by surface texture depth, contributes to overall road safety. Next is to determine the suitable field study to be conducted to address the given problem. And lastly, to analyze test data and present the solution to the open-ended problem.
This experiment is conducted to determine the skid resistance of road surface using the British pendulum tester. Skid resistance is an important parameter in highway engineering because it affects vehicle braking performance and road safety, especially under wet conditions. So this is the apparatus of the skid resistance tester. First one is the British pendulum tester, water container, thermometer, and brush. The apparatus also includes leveling screw, a spirit level, a drag pointer to record the reading, a friction ring for zero adjustment, and a lifting handle mechanism to control the pendulum resist height. First, the apparatus was leveled using the 3 leveling screw. This was done until the bubble in the spirit level was positioned at the center. Proper leveling is essential to ensure accurate and consistent readings. Next, zero adjustment was carried out. The pendulum mechanism was raised by loosening the locking knob until it could swing freely without touching the test surface. The pendulum was then placed in the release position and the drag pointer was set to the horizontal position. For the slide length adjustment, the required contact path length was between 10 to 12 centimeters, measured from trailing edge to trailing edge of the rubber slider on a flat surface. To begin the test, the pendulum was placed in the release position and the drag pointer was rotated counterclockwise back to its original position. The road surface was inspected and a suitable test section was selected. The apparatus was positioned so that the pendulum swing in the direction of traffic. 3 valid swings were then performed and the skid resistance reading were recorded. The readings were required to not differ by more than 3 units to ensure consistency. After completing the dry test, the test area was wetted uniformly. 3 additional swings were performed on the wet surface and the readings were recorded. Again, the difference between readings were not allowed to exceed 3 units. The same procedure was repeated at the additional location on the road surface. For the location, the dry and wet tests were conducted. All individual values were recorded and observation on the surface condition, texture, and test located were noted.
Next, for the result for skid resistant test, the test shows clear differences between smooth and rough road surfaces under the wet and dry conditions. The smooth surface records lower skid resistant values, especially in the wet condition that indicate moderate friction and a higher risk of skidding when the road is wet. In contrast, the rough surface shows much higher skid resistant values for both wet and dry conditions that provide better tire grip and safer driving conditions. Then continue with the discussion. At location 1 for the smooth surface, the average wet skid resistance value of 31.67 falls within the low friction range, which is less than 40 bpn. Then the average dry value of 40 is the upper limit of the same category. Then for the location 2 for the rough surface, the average skid resistance values of 83.67 at wet condition and 89 at dry condition. Both of the value fall into the high friction category, which is greater than 75 bpn. The increased surface roughness leads to higher skid resistance, which directly correlates with improved perceived safety and operational efficiency of the road section, especially under the wet conditions that are critical for accident prevention. Overall, rough surfaces provide better safety and braking performance compared to smoother surface.
The apparatus that used for the sand patch test is measuring cylinder, banister brush, ruler, sand spreader, and brush. First, the test area was cleaned using a banister brush to remove dust and loose particles on the pavement. Next, the 50 ml volume of dry sand was measured by using a measuring cylinder. Third, the sand was poured carefully onto the center of the test surface. The sand was spread evenly in a circular motion using a sand spreader. Make sure it fills the surface voids and form a thin circular patch. The diameter of the sand circle was measured at 4 perpendicular directions using a ruler. And the last one is the procedure will repeat for other location surfaces.
For the results of sand patch test, on smooth surface, the average diameter is 151.25 mm and the mean texture depth is on 0.83 mm. Meanwhile, on rough surface, the average diameter is 111.75 mm and the mean texture depth is 1.53 mm. Both surfaces pass the JKR requirement, which is 0.75 mm. The previous results were compared with JKR requirement, which is average texture depth must be more or equal than 0.75 mm. Individual results should not be excessively low. Texture depth generally should not be exceed about 2 mm. The formula of mean texture depth also were being referred from JKR standard specification for roadworks, measurements of texture depth sand patch method. From the obtained results, the smooth surface produces a lower texture depth because the sand spread over a wider area indicates fewer surface voids. On the engineering evaluations, this texture depth is slightly above the minimum requirement. The surface is relatively smooth but still provides acceptable skid resistance and surface drainage. However, it is close to the lower limit, so excessive smoothing in construction could make it non-compliant. This shows that smooth provides adequate skid resistance at low-medium speeds and also moderate water drainage capability. On the rough surface, it showed a higher texture depth due to more surface irregularities, which trap more sand and reduce the spread diameters. On engineering evaluations, this rough surface provides good macro texture for skid resistance and water drainage. The value is well within the desirable range and indicates a properly textured pavement surface suitable for higher traffic speeds. It shows that rough surface provide better skid resistance, improved water escape from tire road contact, and also suitable for higher speed roads. Both surfaces meet JKR requirements, but the rough surface offers better performance in terms of skid resistance and drainage.
In this section, we'll assess the effectiveness of surface drainage using visual inspection after rainfall. This method focuses on observing water flow behavior, drainage conditions, and any signs of standing water that may affect road safety. From the observation, the roadside drainage is clear and free from debris or blockage. Water is able to flow smoothly along the drain and no overflow onto the road surface was observed. This indicates that routine maintenance of the drainage system is effective. This slide shows that surface water is removed quickly from the pavement. The water flow follows the road crossfall and chamber, allowing rainwater to be directed away from the traffic lanes. This reduces the risk of water ponding and skidding. The drainage pipe outlet is functioning properly with no debris or sediment obstructing the flow. Surface water is successfully transferred from the road into the roadside drainage system, indicating good connectivity between surface and subsurface drainage. Based on this observation, no ponding or standing water was found on the road surface after rainfall. Water drained effectively from the pavement, which confirms that the surface drainage system is effective and contributes to safer driving conditions. Overall,
The assessment of the roadside section shows satisfactory safety performance. The skid resistance and surface texture depth indicate good surface conditions, which helps improve vehicle control, especially during wet conditions. Visual inspections carried out after rainfall confirm that the surface drainage system is functioning effectively, with water flowing smoothly into the roadside drains and no standing water observed on the road surface. This effective drainage reduces the risk of skidding, hydroplaning, and pavement deterioration, contributing to safer and more comfortable driving conditions. That's all from us. Thank you.